My name is Dana Golden. We're going to continue with the first lecture in environmental economics. So this lecture and the next one, or this video and the next one are going to be kind of review, just looking back to make sure everyone has a stable baseline. I encourage you to watch it, but really that's up to you. So utility functions represent consumers' preferences over a bundle of goods. They're a function of a different set of goods that help economists think about how consumers and individuals can make trade-offs, and basically the basic object of economics. There's some basic assumptions. Maybe you saw this in Applied Micro, maybe you didn't. There's completeness. Consumers can rank all bundles of goods. Transitivity, if A is greater than B, B is greater than C, A is greater than C. And not unsaturation, more is preferred to less. People always want more in economics, even if they're diminishing marginal returns. Some common forms, there's the linear utilities, the Hobbes-Douglas, which is just two barrels of blood together with some exponents, and then there's a quasi-linear. Some properties of the utility function: marginal utility is the derivative of utility with respect to the consumable good. So this is how additionally satisfied are you from one marginal more unit of the good. For most goods, there's diminishing marginal utility, which means that the second derivative of utility, the derivative of the marginal utility function, is decreasing as you get more of the good. Eventually, at some point, you're like, oh, don't give me more sandwiches. You start off, and I love sandwiches. Sandwiches are great, but eventually you're like, I don't want to eat another hamburger. Indifference curves represent combinations of goods that yield the same utility. The slope is given by the marginal rate of substitution. So marginal rate of substitution basically tells you what the trade-off between two goods is, how much of one good you would give to another, and that defines an indifference curve. Production functions: a production function Q equals F of LK represents the maximum output produced from labor and capital. You can also, we won't focus on this in this iteration of this course, but maybe in future iteration of the course I'll talk about this. You can also add energy to a production function. You can add energy in land, but in this case it's labor and capital you put in and you get out some good. And again, you can have linear Hobbes-Douglas. You can also lay on teeth the idea that the production of both is required in some fixed proportion. This again, I want you to get in the habit of thinking about how the math relates to the opinion about reality. In each of these cases, you're saying something very specific about reality that you might not even realize when you talk about the production function. So a linear production function says these things are perfectly substitutable, so I can trade one thing for another, and it doesn't really matter. Hobbes-Douglas says I need a little bit of both. And Leontief says I need the same fixed proportion of both. So think about when you're choosing a production function, what really is the assumption I'm making, and how does that relate to reality? And you should think about that as an economist every time you're creating a model and every time you're thinking about the economy. And also, even if I don't explicitly state the assumptions, always when I say model, think about what the assumptions are and what would happen if you changed them. That's the most important skill for an economist, is understanding where models go off the rails and how to fix them. The marginal product of labor is the derivative quantity with respect to labor. Same thing, marginal product of capital. There's also diminishing marginal returns, which basically means at some point you have less of an ability to produce more with increasing labor and capital. This sometimes can be argued to come from the fact that there is a trade-off between labor and capital, and that trade-off is increasing over time, and as you have more labor, as you have more capital. But sometimes it just means that, eventually it's hard to produce things, usually from a third input. Usually, diminishing marginal returns is related to some third unobserved input, but it's not always. So supply functions and cost functions. The total cost is the sum of the fixed costs and the variable costs. The marginal cost is the cost of producing an additional unit. How much does it cost to produce one more unit of the good? In economics, we make decisions at the margins. We usually set marginal benefits to marginal costs. We think about marginal utility of work to wage, marginal utility of a good to price. Think about how to make decisions as margins. This is why fixed taxes don't really work, because they don't affect behavior. Supply curves represents the quantity supplied at each price as derived from profit maximization, which I'll show you in a moment. The elasticity of supply, which basically is how responsive the supply is to a change in price. How responsive quantity is to a change in price is equal to the derivative of quantity with respect to price times price over quantity. Here's a visualization of the production function. You have this little concave thing here, where at the beginning you put in a little bit of labor, a little bit of capital. Wow, you get a lot, and then slowly but surely it becomes less useful to have more of these things. And then, like, if you have 100 people on one computer, you're not getting anything done, so it's not even useful to have more people. So firms do one thing: they maximize profit. Firms exist to find a way to make total revenue minus total cost as high as possible. Total revenue equals price times quantity. In this class, almost exclusively, we're going to assume that prices are constant. They don't necessarily have to be. You can assume a world where there are multiple goods with different prices, or where there are different prices charged to different people, price discrimination. Here, we're just going to assume there's one price in kind of a perfectly competitive market. So revenue is price on quantity, and then you have some definition of costs. First order conditions, you set the derivative of profit with respect to quantity equal to 0. You get MC equals MR, and that becomes your definition of how you should produce. And then, obviously, you generally find that at some point, profits decrease with quantity, either because you saturate the market or because it just turns out the costs rise as you produce more. So this ends up with being that firms set MC equals MR, and they maximize profit. A demand function is the opposite of the supply function. It's the downward sloping curve in the supply and demand curve. It represents the quantity of a good that consumers are willing to be able to purchase at a given price P. As price goes down, quantity goes up. That's the law of demand. So one particular specification of the demand function, which is pretty common in your principal classes, is a linear demand function, where you just have a straight downward sloping demand curve. There's also an elasticity in demand, which measures the responsiveness of quantity demanded to changes in price. Elasticities are very important when you're thinking about policy. They determine how effective taxes are, and how much your policies change people's lives. If there's a real inelasticity, then it means there's not going to be a huge change in behavior from a tax or from a regulation. But if things are really elastic, then regulations are going to have a big impact. Usually, you don't want regulations to have a big impact. You want to change people's lives as little as possible. Occasionally, like, elasticity is a very good thing, and you want, like, small changes in policy to massively affect behavior. These are things to think about, not necessarily things that policymakers or economists are able to control, but they can try to understand how they exist. Income, it shifts demand. As you get more income, you'll stop using inferior goods, you'll move to normal goods, and then if you have enough income, you'll move to what are called luxury goods. You purchase a lot of ramen when you're poor, and then when you make a little bit more money, you go out to Chili's once a week, and then when you make a lot of money, you're like eating at Fuego de Chao every night. You start off with a Honda, then you trade up to a Lexus, and then maybe you get a Cybertruck. And then, you know, sometimes goods are related, and sometimes when you change the demand curve for one good, it affects other goods. Market equilibrium happens when quantity supply equals quantity demanded. You can solve the equilibrium by say quantity supplied equals quantity demanded to find price, and then you can substitute in the optimal price to find the optimal quantity. So here's a little example. We have quantity demanded equals this linear demand function, quantity supply equals this supply function. Probably in an industrial organization class, we would not make these very simple assumptions about demand and supply. We would probably have more complex ideas about how supply and demand curves work. These are the assumptions you need to be thinking about in the background. But in this case, we're just going to set these things equal to each other. We solve for it. 50 minus 10 is 40. 3 plus 2 is 5. 40 divided by 5 is 8. So we have 8. We plug 8 in so that 50 minus 16 is 34. P star equals 8. Q star equals 34. If there's deviation from this, it results in excess demand or excess supply, and prices have to adjust to meet that. In most economic classes, you won't see anyone talk about the idea that there's much room in the model for excess demand or excess supply, just markets equilibrate. In the latter half of this class on commodity markets, we'll talk specifically about how price formation happens, because that's something commodity analysts deal with a lot. And then here's market equilibrium. Yeah, you set price, or you set demand equal to supply, and then you have a nice price and quantity where they meet. This has been the review of Applied Microeconomics. These are some tools that I'll expect you to have a basic understanding of throughout the class. And then next time we'll review math, which you can also skip if you feel really comfortable in the mathematics. And then we'll hit the ground running on what is environmental economics. Have a great day, and I'll see you next time.